Hello friends, I am a student of plus 2 and you can call me your friend. Then I am going to start my first video in my YouTube channel. So let's start. Today I am going to discuss all the phenomena in a short time on the chapter chemical kinematics. Hope you will like it. So let's start. The chapter name is chemical kinematics. At first, the rate of reaction equals to del C by del T. Del C is the change in concentration at the time span of del T. Then, if the reaction is M1A plus M2B equals to N1P plus N2Q, then the rate of reaction for this equation will be 1 by M1 into minus dA by dt. dA by dt is the change in concentration of A at the time span of T equals to 1 by M2 dB by dt. dB is just change in the concentration of B at the time span of T. Same. Then we can write the rate equation as K equals to A to the power A whole to the power N. This is the rate equation. For nth order of reaction, unit of K, this is very important, please note down. For nth order of reaction, unit of K equals to mole inverse per liter. Sorry, this is not mole inverse, this is mole per liter whole to the power 1 minus n into T to the power T inverse. Then if the reaction is nth order, then the unit of K is mole per liter whole to the power 1 minus n into T inverse. Also you can write it as atmosphere whole to the power 1 minus n into T to the power minus 1. Then note down this point. Rate is always determined from the slow step. If there are multiple steps in a reaction, then rate is always calculated from the slow step of this reaction, multiple reaction. For zeroth order of reaction, if the reaction is zeroth order, then the rate equation for this reaction is A at the time T, concentration of A at the time T equals to concentration of A at the time 0 minus K into T. K is the rate constant of this reaction and T is the time. Also there is a formula X equals to KT. We can write the KT as X, then X will be the amount of reactant that will change in product. Half-life period for zeroth order reaction T half is equals to concentration of A by 2K. K is the rate constant of this reaction. If we can want to calculate the full time required for the reaction, then T 100% equals to A0 by K. Then the most important, the first order reaction. For the first order reaction, dx by dt equals to K into A minus X. A is the initial concentration and X is the constant amount of reactant that change in product. Then X, then after time T, A minus X is equals to the concentration of product that remains at the time T. Then also there is a formula K2 equals to ln A by A minus X. You can note it down, it is very important. And we can also write this formula into this way. This is K equals to 2.303 by T. We can write ln as 2.3 into 2.303 into log. And A is the initial concentration and A minus X is the concentration at the time T. Then concentration at the time T equals to concentration at the time T equals to 0 into exponential constant e to the power minus kt. Then half-life period for the first order reaction is 0.693 by k. You should note down that there is no concentration term in this equation, so half-life time period of first order reaction is not depends upon the initial concentration. Then if we want to calculate any order of calculate the rate equation for any order of reaction, then general rate equation for nth order of reaction kt equals to 1 by n minus 1 into 1 by a minus x whole to the n minus 1 minus 1 by a to the n minus 1, where n not is equal to 1, because if we put n equals to 1, this will be equal 0 equals to 1. Also if we put n equals to 1, it will be also be 0, also there will be 0, so the rate equation will be invalid. Also if we want to calculate half-life of any order of reaction, then the formula is half-life t is proportional to 1 by a to the power n minus 1, where a is the initial concentration of the reaction. Then for a reaction, if there if for a reaction, if there the activation energy for forward reaction is E suffix A forward, and the activation energy for backward reaction E suffix A for backward reaction is given, then the change in enthalpy del H will be E A forward means the activation energy for the forward reaction minus activation energy for the backward reaction. From this we can get the change in enthalpy. Then the important then one more important equation, Arrhenius equation, rate of reaction is proportional to e to the minus EA by RT. Here EA is the activation energy for this reaction, R is the universal gas constant, T is the temperature, is the exponential constant. Then rate of reaction, also a important formula, rate of reaction is proportional to its physical size. Also it is proportional to surface area of the reactant. Then if for a reaction, if the rate constant is K2 and for at the time T1, K2 at the time T2, and rate constant is K1 at the time T1, then the formula, then the relation with the activation energy EA equals to log of K2 minus log of K1 equals to EA by 2.303 R into 1 by T2 minus 1 by T1 minus 1 by T2. So around 9 minutes I have completed all the formulas of chemical kinematics. Hope you like this video. Please subscribe the channel.